So it's LeetCode problem 494, target sum. So you are given an integer array nums and integer target. Okay, so in this problem, so see, for every number in the array we must choose one sign, plus or minus. Okay, so you have choose a sign for every number, you cannot skip any number. So after choosing sign, add all the sign numbers together, so you will get a final answer. So our task is to count how many different ways you can choose the sign such that the final sum equals the sum given target. Okay, so the important is order of numbers does not change, only the sign change. Each different signs arrangement counts as a different way. Okay, so see, if we have example like this, nums is 1. Okay, and target is 1. Okay, so possible ways of this is plus 1 is 1, if we minus 1 is 1, minus 1. So the final answer is only, there are only one way. So if you have two numbers of array like 1 and target is 0, so first plus 1 is 2, and plus 1 minus 1 is 0. Next is minus 1 plus 1 is 0. Next is minus 1 is negative 2. So there are two ways. So if we have number of array like this 1 2 3 and target is 0, so let's try our sign choice. Plus 1 plus 2 plus 3 is 6. So plus 1 plus 2 minus 3 is 0. Next is plus 1 minus 2 plus 3 is 2. Next is 2 now, plus 1 minus 2 minus 3 is negative 4. Minus 1 plus 2 plus 3 is 4. So minus 1 plus 2, minus 1 plus 2 and minus 3. So this is negative 2, minus 1 minus 2 and plus 3. So the answer is 0. Minus 1 minus 2 and minus 3 is minus 6. Okay, so there are only two ways. So every number must be used only sign change, not order. Even if number repeat different sign of position, so count as different ways. So we are counting ways, not just checking yes or no. Okay, for each number we have going to choose plus or minus. Count how many signs combination give exactly the target sum. So in recursion, see, so basically recursion means we solve a big problem by breaking it into a smaller same type problem. For each number we have two choice, put plus sign or minus sign. Okay, so naturally at every number the problem split into two parts. So at index I, if we have this number at index I 0 and 1, so using number from index I to the end. Okay, so how many ways can I reach the remaining target? So okay, let's solve in recursion. If so, we are going to use function solve of I. This is a index and we are minusing from target. Okay, so it means numbers of way to reach target using number from index I onward. So base case of this is, which is when we reach the end of the array, if I is equal to nums dot size. Okay, no numbers, so here no number are left or rare. So if target is equal to 0, so we found on one valid way. Okay, we found one valid way. If target is if target is not equal to 0, so they are not a valid way. Okay, So recursive idea is at index I current number is nums of I, so we choose plus sign. So we have two choice, so we have two choice, plus and minus. Okay, so solve of I plus 1 and target minus nums of I. So here why minus? Because place of nums of I contributes to the sum, so remaining target is reduced. So next we going to use minus sign. Solve of I plus 1, so target plus nums of I. So here why plus? Because minus of nums of I reduce the sum, so remaining target increase. So the formula of this recursion formula is solve of I target is equal to solve of I plus 1 target minus nums of I plus solve of I plus 1 target plus nums of I. Okay, so let's run this. If we have nums like this, if we have nums of array like this 1 and target is 0, okay, this index 0 1. So see, solve of 0 is index this one, okay, and target is 0. So we have two choice, if we minus or take. Okay, if we have to minus or take, if the index 1 1, so 0 minus 1 is negative 1, so 0 plus 1 is 1. Okay, so here we have two choice, 2 comma 2 comma 2, here 0 1 2. If negative 1 minus 1, negative 1 minus 1 is negative 1, negative 1 minus 1, negative 1 minus 1 is 0, so it's 0. Next is 2, 1 plus 2 is negative 2. From this we have two choice, 2 and this 2. We have two choice, if we minus 2, 1 minus 1 is 0 and 1 plus 1 is 2. Okay, minus 1 is 0 and 1 plus 2 is 2. See, 2 minus 2 is not equal to target, so it was not an answer. So 2 comma 0, so its target is equal to 0, so there is one way. If 2 comma 0, so target is equal to 0, so there is one way. 2 comma 2, so it's not equal to target, so it's not answer. Okay, so there are two ways, okay, so the answer is 2. From this side one way and this is one way. In recursion, every number give two choice. Recursion explore all possible sign combination because base case count valid combination, sum of all valid part. Okay, so let's write down the code in recursion. First we create a function of solve int solve of, we copy this int I, base case if I is equal to nums dot size return target is equal to 0, target is equal to 0, return solve of I plus 1 target minus nums of I nums plus solve of I plus 1 target plus nums of I nums. So here we are just going to return solve of 0 target nums. And what was long or it was telling Victor is the in nums. So I is nums here. Int I. So I place target minus nums of I and nums. Yes. Place of I plus target. Just return like this. Target yes. So in this in every index we choose plus nums of I reduce target and minus I increase target, but both choices are explored and at each varied part ending with target is equal to 0. So now we are going to use memoization. Memoization means if I already solve a state I and target, if it's, so see it was repeating, the states are repeating. Okay, I will store the answer and reuse it instead of solving again. Okay, instead of solving again, so we make function. So solve of I and target of I. So see, solve of I and target is solved many times, so the time becomes 2 of n and a state is completely defined by target. So we use memo data memo. What memo will do? In memo we store the answer. If we solve it once, we store in the answer. Okay, that's it. So in future we are going to, we don't write again this. Okay, we just use the answer. So let's in memo how it's look like now. So 1 comma 1, if we solve once it's become 1, and 1 comma 0, then 1 comma 1 it's 1, and 0 comma 0 it's 2. So this is I and target ways. Okay, we just store the answer, we do not rewrite again like this. See, we are writing it again, so we just store this. Okay, so let's write code in memo. First we create a map this was a base case, which is to if memo dot count I comma target, just return memo of I comma target, and we just return memo of I target get is equal to solve of I and place. So that's all. We in this part we are just storing. If we get the answer, we return from here only. Okay. Yes, memoization stores the result of index and target, so the same state is never leak accurate, reducing exponential recursion to efficient. That's all.